Hey guys, so today we're doing section 5.3, and before we get started, I just wanted to do a little bit of a review on Pythagorean theorem. So I know that you guys have probably seen this in middle school, you might have even seen it in Algebra 1 a little bit, but a right angle has some different parts to it. So it has the two sides that are next to that right angle, and these are called our legs. Alright, and then we have the side that is across from our right angle, which is C, and that is our hypotenuse. I always spell this wrong. Alright, so our Pythagorean theorem is used to find a missing side length on a right triangle. So any right triangle, if you know two of your side lengths, you can find your third. And our formula for that is a squared plus b squared equals c squared. Okay, so I just want to take a look at a few examples real quick. So let's look at one where we're finding our hypotenuse. So example 1, we are given our legs, and then we are looking for that hypotenuse. So in this case, we're going to say A is 7, and then B is 8, and then C is X. C is our unknown. So when I plug it into my formula, A squared plus B squared equals C squared, I get 7 squared plus 8 squared equals X squared. Okay, so 7 squared plus 8 squared is 49 plus 64, and that equals X squared. If I add 49 and 64, we get 113 equals X squared. Now I don't want X squared, I want X. So in order to get rid of my square, the inverse of a square is a square root. So I take the square root of both sides, and that is, this is approximate because you have to round. So X is about 10.63 if we are rounding 2 decimal places, which we should be. Alright, and then number 2 would be very similar because you're given that side, or you're looking for that side opposite of the right angle. So that's the same exact kind of thing. If we look at, let's do number 4. So this one we are given that side across from the right angle. So that's our C. So C is 30. And then it doesn't matter which one's which on your legs. So if I make A X and B 25, it's going to be the same thing as if I made A 25 and B X. Okay, so when I plug this in, I have X squared plus 25 squared equals C, which is 30 squared. So I'm going to simplify my squares. So 25 squared is 625. Oops, it's not equal to, it's plus 625 equals 30 squared, which is 900. So if I subtract 625 from both sides, I get X squared equals 275. Okay, so the square root of 275, and again I have to round, I'm going to do it up here, X equals 16.58. And we do have units here, so that would be yards. And it's approximately. Alright, so just a little quick refresher on Pythagorean theorem before we start our real lesson today. Okay, so our real lesson today is about circumcenters and incenters. Okay, so a circumcenter is created, it's the perpendicular bisectors, which we talked about recently. Of the sides of the triangles, they all intersect at this point. Okay, so the circumcenter is always equidistant from the vertices of the triangle. So if we are looking at our diagram here, if P is my circumcenter, then BP and CP and AP are all the same distance. Okay, and actually I should have 4 marks on those because there's one with 3. So, use the diagram to the left to answer the following questions. List the perpendicular bisectors. Okay, so since they are all meeting at P, right, our perpendicular bisectors are DP, and it's not, notice, well, it's not as easy to see on this one, but it's not going straight to the other side. It stops at P. Okay, so we have DP, we have PE, because it's bisecting side BC, and then our side that AC is being bisected by PF. Alright, and again, they are all meeting at that center point, which is P. Alright, so we know that we have AP is congruent to BP, which is congruent to CP, because the vertices are always equidistant from the circumcenter. Okay. Now we also have some other congruent segments because we have bisectors, which split segments into 2 congruent pieces. So each side has a set of congruent pieces. So AF is congruent to FC, and then we also have AD is congruent to DB, and then our last side we have BE is congruent to CE. Alright, so we got a lot of congruent pieces going on, which actually can be super helpful when we try to solve. So let's look at some of those. Alright, so we are given that Z is the circumcenter of our triangle here, and we want to find each missing measure. So first of all, since we have the circumcenter is Z, remember we have all those lengths from our vertices, which are our T, U, and V, are all equidistant. So we are given ZV, but now we also know UZ is also going to be 21, and TZ would also be 21, which we don't need to write. But and now I can look at, I also have segments being split in half because each perpendicular bisector is creating this point Z. So, like, we are given VU is 35, so each half would be 17. And that would be VY. Alright. And then we are given XU is 19, so TX is also 19. But we want to find TU. TU is going to be 38 because it's just 19 plus 19. And then I want to find WV, which I'm going to wait on for a second, and TV. So TV, okay, so I do need to find WV to find TV. So now we know that, again, WZ, XZ, and YZ are all perpendicular bisectors. So what we have created here is a bunch of right triangles. So I'm going to remove this triangle here to the side and rewrite it. So, right, if this is W, this is V, and this is Z, I've just kind of turned it a little bit. So you're given that WZ is 15. I know that looks like 13. That's a 5. Sorry. It's hard. And then this hypotenuse is 21. So we want to find WZ, which is x. Okay, so we are going to plug it into the Pythagorean theorem. Our A is going to be x, or 15, doesn't matter, but I'm going to do x. And our B is our other leg, which is 15. And so A squared plus B squared equals C squared. Our C is 21 squared. So if I start solving, I get x squared plus 225 equals 441. So to get x squared alone, I subtract 225 from both sides. And I get x squared equals 216. So now I'm taking the square root of both sides. And I get x equals about 14.7. Okay, now remember x is really WV, the length of WV, so I can put 14.7 here. Now, if I know each side is 14.7 because they are congruent, then I know the whole thing is 14.7 plus 14.7, which is 29.4. Alright. I'm going to skip down to number 3. So you could try number 2. So before we meet, let's have you guys try this one. Okay. And I'm going to skip down to number 3. So again, now we are given our circumcenter is M. Alright. So I'm going to mark, I know that all of my vertices to M, which are G, H, and I, are all congruent. So I'm just going to mark that. And then I know all my sides have congruent segments as well. So like this GJ is 31, so this side is 31 as well. I don't know what either of these are, but I do know they are congruent. And then LI is 30, so GL is 30 as well. So let's look for what we are trying to find. So we already are asked to find GI. So GI is this whole side here. Each side, or each half is 30, so the whole thing would be 60. Alright, and then we have MH. So MH we don't quite know yet. So I'm going to skip that. IK. Again, we don't quite know that one yet either. HI. We don't know that one yet either. Okay, and MG. Alright, so we are asked to find some of our distances from our circumcenter to our vertices multiple times. So we are asked to find HI, which one? MG, as well as MH. Okay, so those two. So if I look, I have a few right triangles here, here, and here. Now, LMI, I only have one leg of, and KMI, I only have one leg of, but MJH, I have, this is 31, and MJ is 14. So I can find MH, again, by using my Pythagorean theorem. So I'm looking for my hypotenuse. So my legs are 14, so I have 14 squared plus 31 squared equals x squared. So if I do 14, I get 196, and 31 squared is 961 equals x squared. So if I add those together, I get 1,157 equals x squared. Now I want to get x, not x squared, so I take the square root of both sides. And x is 34. Perfect square. Okay, so I know MH is 34, which now also gives me MG is 34, because they are congruent segments. Alright, it also gives me MI is 34. So now I have two triangles here where I have my hypotenuse. I have triangle MKI. So I have, if I'm trying to find IK, right, I'm kind of shifting the way this looks, but this is my K, so this is where my right angle is happening. This is my circumcenter M, and we know that this side is 23, and then this is I. So we knew that this is 34, so we're looking for our leg. So I'm going to just do a different variable just so it doesn't get too confusing. So I'm going to do y squared plus 23 squared equals 34 squared. And if I add these, I get 23 squared is 529 equals 1,156. Hold on. Okay, so yes, that's right. This wasn't actually a perfect square. I apologize. This was 34.01. So if we want to use that, we could. It's so close. I think that's what happened here. So this would have been 1,157. So if I subtract 529, I get 630. Nope, 28. Sorry. And now if I take the square root of 628 is 25.06. Okay, and that was y. But that was IK. So IK is 25.06, and these would have been 30.01, 34.01. So HI we already have HI then, because we're just going to multiply by 2. So this is 50.12. Alright. So I do want to have one more thing to go over. I know this video is going to be super long. Sorry. Hold on. Alright, so I also want to look at incenters. So the incenter, the angle bisectors that we talked about yesterday. If you have all your angle bisectors in a triangle, they all connect at the incenter. So the incenter is always equidistant from the sides of the triangle. Now, when you're talking about distance from a point, which would be P, to a segment, which would be your side, you have to find your shortest distance, which is the perpendicular distance. So you have to have this right angle here. So if we look at our diagram, our angle bisectors are meeting at P, but they are splitting our angle, so it would be AP, CP, and BP. Okay, so our incenter is P. Now we have congruent segments. Any segment from our incenter to our side, so PE is congruent to PF, which is also congruent to PD. Okay. And then we have some other ones. So since we have some congruent triangles here, we have angle, side, for triangle BEP, and angle side for triangle BDP. So we know that BD is also congruent to BE. And then again, we have another set of congruent triangles here and here. So we know that EC is congruent to FC. And then we have a third set of congruent triangles here and here. So we know 1, 2, 3, 4, 1, 2, 3, 4. AD is congruent to AF. Okay. So we have a lot of different congruent segments. So let's take a look at an example. Alright, so example 1. If P is the incenter of triangle JKL, find each measure. So first of all, I'm going to go through. So since P is the incenter, these are all perpendicular segments, and they are all congruent. Alright, so NP is 8, and I don't have to find PO. Alright, then we have a right triangle here. We are asked to find not ML, but we are asked to find LO. So since this is also 8, this is the same triangle, right? So if we want to find this side, this is one of my legs. So x is going to be squared plus my other leg would be 8 squared, has to equal my hypotenuse, which is 13 squared. So if I solve this, I get x squared plus 64 equals 196. And if I subtract sorry, 169. If I subtract 64, I get x squared equals 105. And if I take the square root of 105, I get 10.25. Okay, so LO is 10.25. Alright. And then we need to find PK, which is a hypotenuse of PKO. So we need to do 8 squared plus 17 squared equals x or y squared. So I get 64 plus 289 equals x squared. And that's 353 equals x squared. So if I take the square root of 353, I get 18.79 equals x. And that would be PK. And then NK, so we can use congruent triangles here since we have an angle here, and then a side. 17 is OK is congruent to NK, so NK is 17. Okay, I am going to stop the video there. I would like you guys to try example 2 if you have time, and I will see you on Zoom.